Hey, how's it going, guys? Jack and Matt here with the Toaster Bros, and today for $600 we're going to be doing a 4K gaming PC.
The goal is 4K 60 FPS, and we think this combination is going to do just enough to get that. So how about we go ahead and talk about each part, but before we do, let's hear a word from today's sponsor. Today's video is brought to you by GVGMall, an online marketplace to gain access to some really awesome discounted game keys, and more specifically, Windows 10 licenses.
And if you're interested, use the link down below and buy the Windows 10 Pro activation using our code TB20 to get 20% off.
All you have to do to activate Windows 10 license is buy the key by using code TB20 and then throw the Windows 10 key into your Windows 10 activation on the system you wish to install it in, and boom, you have activated Windows 10 and you no longer have to look at that horrible watermark in the bottom right corner.
So thanks again to GVGMall for sponsoring this video.
Let's get right into the video, shall we? So the main concept of this video is we're going to be putting together a PC that can play games at 4K. 60 FPS is the goal because there's really not a ton of high refresh rate 4K monitors out there. And we think this combination of new and used parts is going to be more than enough to push that in certain games.
So for $600, you are going to make a sacrifice here and there, just on looks, but other than that, performance is where we're putting all the freaking money. You do have to go with a used card, which we'll get to in a minute, so you do have to kind of sacrifice that part if you're kind of scared of buying used, and you're going to have to suck it up and try it.
But before we dive into each part, we got to give a big thanks to Corsair for sending over this case. Always coming in clutch to help us out with these PC builds. So how about we go ahead and talk about each individual part, well, somewhat individual part, and then dive into putting this thing together.
So as you guys can see, oddly enough, we have everything put together here. We have the RAM, CPU, and motherboard all in one. The reason we did that is because this was going to actually be a different video where we basically upgraded our old Minecraft server with the processor I'm going to talk about, but we decided just to go ahead and leave this all together for you guys. So long story short, for the processor, we went with the 1600 AF. This is basically a Ryzen 2600 6-core 12-threaded processor. Really, really good for the price, around $85 freaking dollars right now. Can't go wrong with that because this is definitely going to be able to power that 1080 once we get there. So for the RAM, a little bit slower than what we would normally go for, but this is silicon power. This is 16 gigs. We have two 8 gig sticks at 2666. So it is a little bit slower, but honestly, we went dual channel with this. So that's one of the most important parts. It is 16 gigs, which for a 1080, it's kind of going to need that. And for the motherboard, we just went with the basic Gigabyte A320M motherboard. That's also just because we, for the Minecraft build, need to go as cheap as possible on a lot of the components. A320s are relatively cheap for around $50 to $54. You could get a B450 literally for another 10 to 20 bucks that looks a lot better than this and honestly runs a lot better, because right now we have it about capped out as good as it'll go, because the 1600 AF, with it being Ryzen 5, you really can't go Ryzen 7 on an A320. We don't recommend it, at least. So this is probably the lowest you should definitely go, and we recommend going with the B450.
Now, the first used thing we got for this is the graphics card. Now, originally we were going to use another GTX 1080 that we have in hand, but the whole video kind of got scrapped because things were not fitting properly in the case. So we went with this smaller Zotac card, which actually is a full 1080, 8 gigs of VRAM. And the main reason we went with the 1080 is because of that VRAM and the fact that it was a really high-end GPU just a few years ago and could play games at 4K 60 FPS without any problems. All this requires is an external 8-pin, and these things come in around $300, sometimes less, at around $270, and they could be really good value for money if you are trying to build a system for 4K or just a high-end PC nowadays on the used market. 1080s could be a good option for you. Or if you want to go new, you can go 2060 Super, but that's not really necessary if you want to save some money and go used. As for storage, we went with this ADATA SSD. 240 gigabytes is more than enough to get this thing up and running so we can run our benchmarks. Again, you could opt for more storage if you want to, or add a hard drive to get really more storage for your dollar, but this is fast enough. Some SSD prices are a little bit higher right now. We normally would go M.2 because of that, but this is perfectly fine for our build. And yeah, a lot of options you can choose from, but we trust these ADATA SSDs. And now, to power this system, of course, we use the same power supply all the time. This is the Thermaltake Smart Series 500 watt power supply. Really still the only value power supply that you can get on Amazon that makes a whole lot of sense with Prime shipping. I know you can probably barely see this with the reflections going on right now, but this is a really solid power supply. It doesn't have any fancy cables or anything, but again, we're all about value here. We're trying to build the cheapest PC to play at 4K 60 FPS, so we're going to have to skimp on things aesthetically to make this thing have the most power for the dollar. And once again, special thanks to Corsair. They sent over their Corsair Carbide 175R. This is a nice case that does come with some RGB illumination in it. This is a pretty budget-friendly case coming in around $60, and it does come with tempered glass, so it's not using like a cheap acrylic side panel. It's actually a well-built case, and I can see you upgrading this thing with some RGB fans in the future to make a really nice looking PC build. And we always trust Corsair's quality. They don't skimp out on any of their PC cases. So how about we go ahead and build this thing real quick. Shouldn't take too long with all this put together, and then we'll be able to test this thing at 4K.
Alright, ladies and gentlemen, now that we have this 4K gaming PC all put together, let's talk about how it performs at 4K. And we tested this in a couple of titles: Call of Duty Modern Warfare, CSGO, Fortnite, and Shadow of the Tomb Raider. Now, our rationale behind these games is, one, Shadow of the Tomb Raider is going to be the AAA example, and then Call of Duty Modern Warfare is kind of in the middle of an esports titles and AAA, and then we have CSGO and Fortnite to represent the esports category. Now, we did expect to have to lower settings with this configuration. It's just really hard to run at 4K. Keep in mind, 4K is literally 4 times the resolution of 1080p, so you can expect some sort of scaling there where you're going to lose up to 4 times the performance in gaining that pixel resolution. Now, the first couple games we tested were Fortnite, and we had to run this at medium settings. We didn't want to run on pro settings because when you're running on pro settings, you are leaning much more on the CPU than the GPU. We wanted to give the GTX 1080 a chance to really push those frames, but at medium settings, we were actually able to get a well over 60 FPS experience at 4K. But really, I was just underestimating how demanding 4K was, and you'll start to see throughout the rest of the benchmarks, we really had some issues running games at the 4K resolution. The only exception being CSGO. CSGO had no problems running over 60 FPS at 4K on high settings. Kind of expected that. CSGO is an old game nowadays. I don't really expect any of you to go out and buy a 4K monitor to play CSGO at 4K, so we're just kind of doing this to show you if you wanted to play older games at 4K, like older like Valve games at 4K, you could definitely do that. And then we dove into Shadow of the Tomb Raider, which we knew was going to be difficult to run, but at low settings at 4K, which honestly still looked really, really good, by the way. Even running at low detail 4K, that extra resolution made the game pop. It ran pretty well. We were below 60 FPS, wasn't exactly where we wanted it to be, but for a single player game, getting around 45 to 60 FPS is the ideal range, and we were pretty close to hitting that. And the last game we ended up testing was Call of Duty Modern Warfare, and honestly, at low settings 4K, it was worse than Shadow of the Tomb Raider, which was kind of surprising. We ended up getting well below 60 FPS. It was lag city the entire time, and this was an example of a game that, well, just does not work well at 4K. Now, the reason we did this was kind of an experiment. We wanted to see if we could make a PC that runs 4K for $600. Did we do that? Kinda, sorta, not really. We were able to get a PC that could run games at 4K, but really any PC could run games at 4K. It depends on what kind of goal you're trying to hit. So if you were going to go with this configuration, I would honestly suggest saving up for a better GPU. The 1600 AF could handle up to a 2070, which would be better than the GTX 1080. And in theory, with that configuration, you probably would get closer to 4K 60 FPS. But really, I would just suggest you stray away from 4K in general, unless you absolutely need 4K resolution. resolution, we highly suggest 1440p 144Hz or 1080p 240Hz over 4K all day, every day, because high refresh rate really adds a next level visual quality when you're playing games. So we highly suggest going that route instead. But if you do have to go 4K, this might be a decent option for you to start out with. So now that we got the benchmarking out of the way, how about we go ahead and bring Jackson back in here to wrap this video up real quick.
Okay guys, so you got to see some benchmarks, and you know, it let down a little bit, but not too much. You gotta remember, this is $600, which it still does do a lot better than some of our other $600 gaming PCs.
Now, gaming at 4K isn't something we normally recommend. Honestly, you're way better off going 1080p high refresh rate or 1440p, which this system would have no problems doing that. I was using a 1080 in my PC for the longest time, and I was able to play most games at 1440p, 100 plus FPS without any problems. Just keep in mind, 4K is 4 times more demanding in theory, most of the time it's kind of different, than 1080p. So you got to keep that in mind when you're building a system like this. You're probably going to want to spend around $1,500, $1,000 range if you're going to get a constant 60 FPS. But it was a fun experiment, really awesome put together, and honestly, I like this build overall for the money.
Gigabyte's Z390 Aorus Ultra is a beautiful motherboard designed to help you build a powerful PC based around an 8th or 9th gen Intel CPU. It features an advanced thermal design with direct touch heat pipes and their 12+1 phase digital VRM solution to help you keep your overclocks rock solid. If you want to get the most out of your next Intel gaming PC, please check the link in the description down below to learn more and pick one up today. Thanks again to Gigabyte for sponsoring this portion of today's video.
So if you guys wish to buy anything that we used inside of this build, use the links down below. They're affiliate links, so they do help us out. Also, don't forget to follow us over on twitch.tv/toasterbros. That also really helps us out, and we like interacting with you guys on live streams. Don't forget to like, comment, and subscribe.
And we'll see you guys in the next one.